So when we couple reactions, or when we take thermodynamically and non-thermodynamically favorable reactions and put them together to produce a thermodynamically favorable reaction, that's called coupling. Um, in the equilibrium chapter, we'll talk more about this, but there's this thing called the Chantier's principle, which says whether forward or the reverse reaction is more favorable or if the system's actually at equilibrium. And it's related to Gibbs free energy. So notice that these things just like will keep coming up. And so we have our Gibbs free energy at standard pressure of 1 atmosphere and 25 degrees Celsius equal to negative RT ln of K. And K is this equilibrium constant, and it tells us whether if the reaction is when it's at equilibrium, like what the products to their power divided by the reactants to their power. This relationship, and it will tell us if we're at equilibrium or not for a given temperature. And so when K is greater than 1, then delta G is negative, and so in other words, our forward reaction is favored if we're at K equals 1, which is ln of 1 is 0, then the Gibbs free energy is 0, and so you're actually at equilibrium. And then lastly, if your delta G is positive, then your forward reaction isn't favorable, so the reverse reaction is favorable, and so that would be when K is less than 1, which we'll talk about more when we get to equilibrium. And then all the delta G's we've talked about so far are for when it's at 25 degrees Celsius and 1 atmosphere. And so a lot of times life isn't in that case. We don't have 1 atmosphere, or we're not anywhere close to 25 degrees Celsius. If we're close, then it's really not going to affect the delta Z a whole lot. But and they no longer do this on the AT test that I know of, but you should understand that, hey, there's a delta G that's not at 25 degrees Celsius and 1 atmosphere, and we can figure out how it's going to vary at a given temperature by using this lovely equation. And so if we change the temperature, we're going to change our delta G value, and so it's unlikely that you'll have to do this on the AP test, but you should understand that if we change the temperature, then our delta G value is going to change, which should make sense because it's kind of like putting energy into the system, and one of the ways we can make a non-thermodynamically favorable reaction happen is to put energy into the system. So that concludes our notes for this unit.